So welcome to the first video in this series on the AQA GCSE Computer Science. In these videos I am going to walk through a live attempt at a GCSE paper. I've never tried this paper before, and the purpose of these videos are to show you how an experienced teacher approaches the GCSE, to show you the different types of questions that appear on GCSE programming in AQA, and to give you a sense of how you would communicate about these questions and prepare your students for teaching this particular qualification. So this video is just about understanding AQA paper 1, and it's because we are doing because we're doing Python. Our variant of paper 1 is paper 1B. So paper 1B, it doesn't actually say that on this paper because it's a specimen paper, but we know it's 1B because of Python 3, and we also know it's 1B because of the name of the file. So this is what a student will see on exam day, and they should get used to seeing the AQA layout long before that, so that the first day they see this isn't the day of the exam. So all we're going to do is we're going to scroll through initially the paper from a high level view, and then in subsequent videos we will go through the different types of questions that are found on this qualification. So in my career, I have taught a new qualification every single year of my career, and the first thing you do when you find out that you are teaching something new is you go and try and find the assessment for that thing. So I've taught BTEC computer science with Pearson's, I've taught A-level computer science with AQA, I've taught GCSE computer science with OCR, I've taught A-level computer science with OCR, I've taught undergraduate programming in JavaScript with the Open University. I've taught a lot of different qualifications. Step 1, day 1, find the assessment that they will be sitting at the end of the qualification and work through it. You don't have to know everything at the beginning, but it is important to be able to have a high-level view of the assessment. So no calculators allowed, 2 hours. In preparation, like we're doing here, we're not going to enforce time controls, but it's worth being aware that 2 hours is the amount of time that the students will have. 90 marks for this paper, so that if you think about the fact that 2 hours is 120 minutes, that is less than 2 and more than 1 minute per mark. There will be multiple choice questions on this assessment, and it's given us explanations about how we are going to answer those multiple choice questions. Multiple choice questions are generally a really nice way of catching misconceptions, and so they should be considered to be trick questions, and almost always that trick is on purpose. So let's just walk through the paper. So this section of the paper I'll roughly call knowledge. You have to know certain things, whether it's the definition of algorithm here, and the definition of things like assignments, and there's no way around that. You just need to know. These kind of questions are classic AQA style questions, and these questions are some snippet of code, and you could think of them roughly as short tracing questions. So long tracing questions will involve a trace table, and we'll see those later, but these are short tracing questions. You have to be able to read the sample code given, and you have to be able to identify the correct answer. It's not writing a program, It's not some of the other skills that you'll have to do with programs. It's just, can you work out what this does accurately and specifically? So this next question, the algorithm in figure 2 has been developed to automate the quantity of dog biscuits to put in a dog bowl at certain times of the day. Okay, so here's the algorithm where selection is used first. So this is, again, we're being asked to identify programming constructs here. So this is somewhere between knowledge and code comprehension. And students that are weaker will struggle with these questions. There's no way around it. You just need to know how to program in order to be able to read code, and so you'd get that through your regular programming lessons. This is just a nice test of how well those ideas have been internalized. So note, we've got selection, iteration. You have to know what those words mean, but then you also have to be able to comprehend them in a real program. Subroutine. So this is, again, this is the same. This is knowledge and code comprehension. And here we have a slightly longer program, and here we are filling in the blanks. So this is completing a program. So this is a little bit like writing a program yourself, but there are controls. You're given a structure, and you just have to fill in the blanks. Again, the best preparation for this question is to write lots of programs that look like this, and then when you see the big structure with the details missing, you will know what needs to go in there. No way around this other than practice. Okay, so these are the questions that strike fear into the hearts of students sometimes. They shouldn't do. I think these are the nicest questions on the paper. These are the algorithm design questions. So there's one here, and there's another one here. This is also algorithm design. Okay, so we're back out of the algorithm design, and again, this is knowledge mixed with code comprehension, and the same with the one below. Okay, this one here is also knowledge plus code comprehension, but we've met in question 7.4, we've met our first tracing question. So this is a proper tracing question, and it's a tracing question because we have this trace table which records the values of the variables at different points in the program's execution. So this is a tracing question, and this is a big feature of AQA programming in a way that it is less common on OCR. Okay, and we're back to algorithm design. And now we've hit our first new type of question in a little while. This is something which again is unique to AQA. You don't really find this on other exam boards. There is an implied code base. So we have, in this case, 4 separate subroutines. So we could think of this as some medium-sized or small programming project, and rather than being given the code base, which does actually happen at AS level and A level and beyond, you're just going to have some sort of specification or description of the code base, and that is what you are going to use to solve higher level problems. So you're still programming, but the programming is considering these modular parts, and so knowing what a subroutine is really important. But knowing the details of how that subroutine is implemented is not necessarily important. What you have to know is, what does it look like? What it looks like forward and a single parameter. And then what does that do? Well, it moves the robot forwards n squares. And then we have 4 others that do other things. And so I am going to refer to these types of questions as skeleton code. In fact, I haven't written that down before, so I'll write it down in full. So skeleton code. The reason I'm calling it that is because at A level and at AS level, that is what it will be called, and you will be given the full code base rather than just descriptions of the subroutines. So we'll just call them skeleton code in anticipation of A level. And then these questions drag on, so they have many, many parts. This here is a knowledge question, and then this one here is a tracing question. Slightly different. This isn't a trace table. This is the state of an array as it's being sorted, but it's the same basic idea. Okay, another knowledge question, arguably slightly more applied. Another knowledge question, again applied to a scenario. Okay, and we've got a new skeleton code question. And as before, it goes over a few pages. And now here we have a very nice question, which is actually skeleton code, but applied to algorithm design. So this is a mix and match question. You're going to develop a program, but you're going to do it using the skeleton code that's been given to you. Well, so this is a code comprehension question. And is there any knowledge you'd actually need to have for this? I'm not sure. I don't think so. And then this one, yeah. So this one is has elements of code comprehension. It has elements of algorithm design, but we're just going to refer to it as correcting, or we'll call it debugging for the purposes of this video. Debugging. So my categories, you'll notice they're not perfect. They do have overlaps, maybe even some inconsistencies, but roughly speaking, this is the high-level view. Like I said, I've never seen this paper before, and so this is what an experienced teacher sees when they read through a GCSE programming question. And each of these skills I'm going to teach in a different way, and my live assessment in the class is going to look different. That's why it's so important that I can identify them. And the type of question itself also may not match any topics or modules that you have in your scheme of work. And so you have to be aware that although I teach debugging in maybe one lesson, their actual worth on an exam is 4 marks out of 90, maybe even more than that. And so even though it's a single lesson, I'm going to have to bring those skills back through different lessons. Algorithm design, for example, is likely going to be taught in a programming unit, but hopefully you've seen that it's 25% of this paper at least, if not more, and so that unit isn't going to be enough to get them the skills they'll need to be able to shine on this programming paper. In terms of knowledge, again, that can be taught a single idea in a single lesson, but when that knowledge starts being tested in more exotic ways, like combined with code comprehension, or in kind of conceptual multiple choice questions, you will have needed to have taught that knowledge in a very conceptual way. So although there might be a single lesson on variables and identifiers, being able to pick those out consistently out of programs is something that we'll have to come back and back and back to. And actually, in my interviews for this course, you'll notice that I ask people to identify the variables in a program and the data type, and postgraduate qualified computer scientists, they generally get the simple, the primitive data types, but actually often they trip up over more complicated data types. So even with undergraduate qualified computer scientists, these skills are sometimes a little bit patchy. So hopefully you understand that although this may look simple when an experienced teacher reads through a paper, the student learning this learns it over 2 years, and the teaching of it is subtle and has layers. Anyway, that's enough for the overview of this paper. In the next video, we'll have a look at some algorithm design questions.